Welcome everyone to another episode of Cloud Cover Show. In this episode we have Mark Fussell and Hashi Bai from the Azure team to talk to us about building games on Azure, which is quite exciting. Why don't you guys introduce yourselves and tell us a little bit more about what you do?
Okay, so I'm Mark Fussell and I'm a program manager that works on Azure Service Fabric.
I'm Hashi. I'm a developer at Azure. I do some stuff.
Great, and you probably recognize Hashi from before. He used to be one of the hosts here for the show, but today we're interviewing him. And we also have Etienne and myself, I'm Thiago. We're both here from the X at Corp, and we're running this episode today as hosts and asking a few questions. All right, why don't you guys talk us through what you want to present today and get started?
Okay, great. Well, this is a recreation of a talk we did last month at GDC, where we talked about building games on Service Fabric. And we're pretty excited because we see a number of different companies doing this. Just a bit of a recap of what Service Fabric is. We talk about it as being a microservices platform where you build applications that consist of small pieces of code that you deploy. It does everything from the development side all the way through to the ops side of things. We like to talk about how it runs on any OS and any cloud. It runs on my laptop. We host it as a service in Azure, and you can run it on-premise. And then we have Windows and Linux versions of it.
Great.
And then when you build your apps, we have various different ways that you can use programming models. We provide out of the box, as part of our runtime, reliable services and reliable actors that allow you to be very productive about building scaled out applications. But you can also build web applications. We host ASP.NET Core, Owen, and other web apps on top of us. And then, of course, you can bring along any piece of code that you like, whether it's a guest executable. And last year, we also introduced the fact that you can launch and host containers. So this is Service Fabric as a distributed systems platform for building microservices. And a good thing to do is, we should dive straight into a demo on this gaming side of things. And a demo, we're going to show reliable actors and what you can do with this, because it's kind of a very intuitive framework to use. And of course, what's the hello world of games? It's
Tic-tac-toe.
Tic-tac-toe, yes.
All right.
So let me switch over to Visual Studio here. So what I've got here is I've got an application that's built using the actor programming model. And the first thing I built was an actor player type. And the actor is very simple. It can join a game or it can make a move. And this is defined as one of the actors inside here.
So that's a Service Fabric actor model. Okay.
Correct, yes.
Cool.
And the actor model, is very interesting because you have these discrete pieces of instances that have their data and functions combined, and you can make them reliable and persistent.
Awesome.
And that's what you really show in the next one. There's this game actor now, and inside here, I can join a game, I can make a move, and I can see the state of who the winner is inside the game. So this is another actor I've defined. So I have this player and I have this game actor. When you look at the implementation of the game actor, this is kind of interesting because here you see that it's a persistent actor, which means all the state that's associated with it is made reliable and replicated. And you can see the state here that we make as part of this game. So this is the game board. Do you have a winner? Here's the number of list of players. And this is part of this particular game actor. And then we simply implement the methods for this actor. If I scroll down here, you'll see that I've got the join game method. It takes the player name and a player ID, and it checks that 2 players have joined this particular game. And if it does, it adds them into that state.
Right.
So the game logic is very simple to implement with this actor. I've got the game board here, state, the winner that gets returned. And of course, this is all the logic here of making an individual move.
Mm-hmm. So one thing I want to point out is in the join game method, can you scroll up? So you can see here the code is just testing if the player count is 2, and there's no locking required because there's turn-based concurrency in Azure. So you don't need to deal with those concurrency logs and critical sessions. You just read the code as if it's a single-threaded code.
Yes, cool. And in fact that's illustrated when you actually go and look at the client itself. So when you use this from the client, you see here is I create one player, I create another player, actor, I create the game actor here. Both players call join game, and then after that we just check that they're both joined down here. And then here's the interesting thing: the players just make moves. They just play. So they're playing as fast as they can. Yeah. Meanwhile, the game is checking and running in this loop here to see whether who's a winner of a particular game and drawing the game board. Yeah. So this turn-based concurrency is controlled for you so that players make individual turns, and you can write very stable, safe code that doesn't have threading issues inside at all.
Yeah, so both players, they're trying to cheat. they're trying to make moves as quickly as possible
Right.
without waiting for their turns. But the game actor is keeping them in line.
Right.
Yeah.
Okay. So this all gets deployed, as a. I think I have this running here as my service. Here it is as my actor game service here and my players. And what I can do now is what we've gone and done, of course, is we've made this highly available.
Right.
We can launch many of them. So I can launch 10 instances. Oh, before I do that, let me just minimize my desktop, and then go back to this. And if I launch 10 instances of this, I'm going to launch 10 concurrent games,
Right.
and they're all a tic-tac-toe play game. They're all playing here at the same time.
Cool.
And wow, look, it's just this is multi-instance, multiplayer, turn-based games you're playing.
The first tic-tac-toe MMO ever.
Yes, that's right. It's fantastic. So
For an intro, this is pretty cool. Is the code available online?
yes. There's a link at the end of this session. It's actually on my private GitHub account at the moment. But originally it was your code from your book, wasn't it?
Cool.
So it's in a couple of places.
Yeah.
I've got a link at the end of this
All right,
session.
go add the link.
Yes.
That's awesome.
So let me kill this now. Let me kill all these sessions. Kill, and let me kill this session here, and let's go back to slides. So that was Reliable Actors. It's a great little intro to how to use Service Fabric and one of its programming models. And effectively, we have a number of different companies who've been using Service Fabric
Right.
to build games on top of us. A couple I want to talk about today are Ilriad Games and Funrock. Let's talk about Ilriad Games first. So they're a game company that we actually featured last year at Build, and we showed them as a demo. And they have a multiplayer game. In fact, I have a instance of their game running here. I have a cluster here that you can see that's deployed. And you can see inside this cluster that they have 8 different applications get deployed. And each one of those applications does a variety of different things in terms of managing accounts or managing space or in doing the AI intelligence of the actual spaceships themselves. And I can actually go and launch and go into a new browser view here and launch and attach to this back-end game that's running here. I can log on as a name here. I can log in as Mark. And when I log on, you'll see now I've launched into this game here inside space, and I'm flying around, and I can control and I can do some shooting inside here. And you see it's a very responsive game, lots of beautiful graphics, and I can see that I can change my speed and angle, and all of this is basically allows you to have a very multiplayer MMO game with lots of low latency, because all of the state is managed in terms of Service Fabric and made highly available. So it's a great little fun game.
And previously, in the previous sample, the code was in C#, so I assume it works also in JavaScript, because here how does it work? Is the JavaScript code using Service Fabric directly, or?
Well, this is there's a back-end hosted game, so they use SignalR to connect to the back-end, and then yes, they have a web-based UI that does all the rendering through WebGL and JavaScript to be able to create the front end inside this.
Cool.
So yes, this all gets pulled from the back end and renders inside your browser, so it can run on any device.
So
and
from the front end, it talks to the back end that's running on Service Fabric via SignalR and.
Correct.
Right.
Yes.
Cool.
And they created a WebSocket gateway and made it very responsive like this, and runs on ASP.NET Core,
Yeah.
and through their Kestrel engine as well, which is a very high throughput, low latency hosted web service. Yeah. So Ben Adams and his crew there did a fantastic piece of work on this.
Very cool.
So it's very cool. This game is. Let me just kill out this. So that's Age of Ascent, and there's a lot more things you can see online in terms of videos that we posted and articles there. The other company we worked with was a company called Funrock.
Right.
And they're a much smaller company. They're based out of Stockholm in Sweden. And they launched a game last year called Heroes United. And it's a game that they launched actually in the Middle East markets. What the type of game is here, I have a little video from them, which if I launch, it's like one of these godlike games where you're in the desert here and you build a world and there are other players inside of it all, and you battle out with other players and effectively grab resources from other people and things. And as you can see, it's focused on the Middle East because that says Heroes United. So that was what they did, and they had a number of main goals that they wanted to do. Particularly, they wanted to start small because they're a small company and grow over time. They had to create a very scalable game with low latency. Rolling out new changes was very important to them because they wanted to do new updates and have multiple game worlds. You know, they're going to launch it inside the US, and of course, inside the US, they want to have a different type of world and what it all looks like. So they discovered that they started to build on Service Fabric for this back-end solution. And the way they did it was quite similar in the way that Iliad Games did. They had a set of core game services with a logic. They had some reliable services that were reusable. And then they had some admin services that managed admin accounts. You know, in total, they had 17 different reliable services and these active type things that they put together to build this overall app that they run, called Heroes United. And what they found was Service Fabric was great because what they found typically is that they had spent a lot of time building their own gaming platform themselves. They had to build all the concepts of reliability and scale and failover and rollouts, and all of that was given to them by Service Fabric. So as a small company, they could start small and grow over time. But we've also seen Service Fabric that can be used on larger scale games as well. So for them, the challenge was thinking about microservices. Their prototype was sort of a classic 3-tier app where they had a back-end database and they had a middle tier, and it was a lot more harder to evolve over time.
So is that something that you're seeing now as you're talking to game companies that they're moving to microservices and actor-based implementations?
Well, we're certainly seeing that they're moving to a microservices approach because it allows them to be much more agile. Because they can do changes to their code more frequently, and also it helps with their componentization of how they can reuse things. And what they found that there were common challenges between what they had built and what they'd seen in the rest of the industry, and they wanted to share some of that code and some of that experiences with the community. One thing we're fairly obsessed with inside Service Fabric is building gateways, and I'll get to what you said in a moment. And these gateways are effectively how you communicate with your back end. In the case of both these games, they built a SignalR front-end gateway that allows you to have a WebSocket connection to the back end and maintain that state and have those request responses. But when we use Service Fabric, there are many other ways that we use it with API management and IoT Hub. But what Funrock have gone and done is they've taken their front-end gateway and all of the code around that, and they've released it as an open source framework, which they call Game Framework. Yes, sorry, Game Fabric.
Game Fabric.
We thought this was a fun thing to be able to call it, Game Fabric. This is the GitHub URL that you can go to and get all this code. And it allows you as a gaming company, as a kickstart, effectively to have a very well-tested performance SignalR gateway where you can create a number of back-end services to help you get going. So what it provides is this SignalR gateway, runs on top of Service Fabric, and helps you, not have to write all this code yourself. What it looks like is, what it gives you is this gateway component, and it gives you the concept of registering a user, logging on a user, and managing a session, and then some helpful classes to do logging and statistics. And the way you think about using this is that you write these things that they call processes, where it's a very common design pattern. Your request comes in, you plug in the processes for a particular type of action. So whether that's shoot a bullet or move a car or whatever action that's happening. So what's effectively happening is you're having connections open to a session, and then the processes are routing those very efficiently to where the session's running. So what we did was we took a very well-known game inside Unity called Tanks. Do you know this game?
Yeah, I've seen it before.
And it's today it's you're both on the same laptop, and one of you has this side and one of you has this side, and you move a tank on the same laptop.
Take turns too.
You can kick the other player.
You can kick the other player. That's right. But you're both here on the same laptop. And we said, well, why don't we take this 2-player game on a single laptop and make it a network version? So that way, multiple players can run. And use that as a sample that is also published to this GitHub account, so that you can see how Unity game works through this open source gateway in order to run tanks. And so effectively, we added tank game session, and tank game session list as the additional services that run inside here into a project that you can download and use. So those blue boxes there are the additional ones of code that you write. And then to use it, effectively 2 clients, I can take this service, like you saw with the Age of Ascent, I can host it inside Azure on top of Service Fabric. 2 clients can talk through the Azure Load Balancer, talk through the SignalR gateway that does all the correct routing. It talks to your tank game session, and both of those, it forwards the turns and the actions that you make between the different tanks on players running on 2 different machines,
Right.
and then back to the clients, back to house through the Azure Load Balancer. So we try to make this as responsive as you can. And SignalR and opening up WebSockets is a great way of doing that. So let me give you a little demo of what this looks like.
Cool.
So first, this project, this is the Unity. If you go and look at the Unity project, they have all the assets inside here. We added a number of different SignalR clients in order to communicate with this. And then we went and created a cluster. It's this one here, this cluster. And inside here, we deployed the gateway service. This is the gateway service running. We deployed these back-end sort of helping services that do some logging and statistics.
Storage, yeah.
Storage and things like this, yes. And then the very specific one is that we built the additional tank games here that allow you to manage the tank sessions between the 2 players.
Cool.
So there's just a small amount of code that I had to adapt in order to achieve this. And this is running on a cluster actually hosted inside Azure. So what I'm going to do now is I'm going to just switch over, and I'm going to launch 2 clients. I had them pre-built already because Unity is nicer to run them as a pre-built app.
Yep.
So I'm going to launch this one app here, and then I'm going to launch another one here. And here they are, both running. And so what happens is you see, imagine these are both running on 2 different machines. This one is on one machine on the left. You see, I see my tank is green here, and this is a machine I see my tank and my green here. And so in this one here, you see that I'm moving. You can just about see this one here. I'm moving my little tank here, and of course you see it moving the other person's window.
Oh.
And the latency isn't too bad over wireless. This actual cluster is hosted actually in Europe. So the call's going through wireless, it's going through all the way to Europe, it's coming all the way back again, and this is me driving my little tank. If I go to the other control over here,
Switch the window.
oh, yeah, I can switch the window, yes. If I go over here, you can see that this is me driving my other tank over here, and I can shoot shells, and if I can do any remote form of shooting, let me get a bit closer, I can shoot this guy here, and maybe I might win a round.
Are you losing against yourself?
I'm losing against myself. Yes. Oh, there we go.
I think Mark won.
Yeah, I want to get, yes. It's great. And then it starts another round.
Cool.
So all this is available on GitHub?
Correct, yes.
And how easy is it to try these and set it up? And if I want to try that myself and deploy everything?
Yes, well, you can go to this, there's this GitHub account here called Stockholm Tech Angels Game Fabric. You'll see that there are 2 things here. There is this is the framework that we provide, just a raw framework. If you then look underneath, the samples folder inside here, there is this tanks game.
Yep.
So inside this the samples folder here, we provide both the Unity game as well as the game fabric with the tank sessions added to it.
With the extra vectors.
So you literally just have to download this. We're going to post a few more instructions on this. Run it as a Service Fabric application. Load up the Unity project into Unity. And then you can then connect onto your local machine and run it there actually, just with changing a URL to your local machine. And that way have this all up and running.
Cool.
It's fabulous.
Yeah, that's great with the Service Fabric that you can run on your computer, so you can run the whole thing locally first and then deploy it to Azure.
Yes.
Nice.
So one of the beauties, yes, I can have a cluster running on my local machine. In fact, if you go back and look at the tic-tac-toe example that we looked at earlier here, you see this was running on local host here.
Yeah.
So I run that locally, but you see the Ilriad Games one here and the this tank game here are running inside remote clusters and things.
So it's really easy to try it.
So it's really easy to try it, yes.
Cool.
So I encourage you to try this out. So So that's what I have, which was super exciting stuff.
Awesome. Yeah. How do I follow that? Okay, yeah, I have some great stuff as well. So basically what Mark told you is about how to use Service Fabric to write new games, how to use the framework to write games. What I'm going to talk about 3 different cases about other things related to games. The first project I'm going to talk about is the Xbox Ambassador. So when you host the global games, it takes a lot more just to host the game itself. You need to do a lot of management work, like managing the users, do the statistics, fraud detection, all those things. Unfortunately, Service Fabric is also great for writing those systems. So what the Xbox team did, they took Service Fabric and designed this ambassador program, which is a community support program. Basically, everybody can sign up as an ambassador, and you can help your peer players by answering their questions. First, I'm going to show you a demo. I'm going to switch to my machine.
Switch to Hashi's machine.
Yes. So you can see to the left, I'm logged in as myself, a prod ambassador. And to the right, I have an in-private browser. I'm going to log in as a different user. This is a test user. XCL test 2.
Yeah, you have an E after AutoCAD.
AutoLooker. Yeah.
It's the next version of AutoCAD.
Oh, I can't use this keyboard because there's a touchpad in the middle. If I can remember my password correctly. I hope it works. All right. So that's all the demo. Logging in. So basically now I'm a player. I have some problems. I can go to the ambassador program. I can just start to ask questions. Let's say I have a question with Xbox One. How do I log in? So here I'm just asking a question. Then to the left, there's a community of ambassadors waiting for questions. And once the question surfaces, it will be showed up on my bank. I can choose to take the question and start to engage with the customer. You can see here I have the question. I will click on this guy. I'll take it. I'm going to take this question.
That's a way to handle a community and answer issues.
I'm going to share my name tag, game tag. Now we can start to chat, right? Let's see. Just look at your Connect and say, but my Connect is still in box.
Open it.
Yeah, open it. So problem solved.
Yes.
That's perfect.
Sweet.
Yeah. So that's the program. Now I'm going to switch back to the machine to show you the architecture, how this program is done. I'm back. So basically now this is still a relatively new project. They are hosting about 2,000 to 4,000 customers daily, and there are about 14,000 to 30,000 messages per day. And everything is supported by 5-node cluster. So this 5-node cluster is serving the global community of Xbox Ambassador. And what's interesting is about the ease of development using Service Fabric. You can see some data from here. Basically, from the conception to delivery, this project took 3 months with very few developers. And if you look at the last number, throughout the lifetime of the project, they found 0 concurrency bugs. I mean, Microsoft has pretty amazing developers, but developers always make bugs. But they found 0 concurrency bugs because of this actor model, the turn-based concurrency, make the programming of this really distributed system very easy.
So what does the architecture look behind the scenes?
Yeah, we'll show that. That's the clusters, just to show you this is true, but I'm going to jump to architecture. So this architecture actually is quite simple. And a couple of things I want to point out. First is that you can see everything is microservices based. There's no centralized coordinator or dispatcher or manager, which usually introduce a single point of failure. And you can see everything is scattered by itself. To the left, you can have one or many collectors, a different type of collectors, collecting messages from Twitter, from chat, from whatever sources you can collect. Then everything is pumped into this command bus, which is based on the Microsoft event bus, which is highly available and scalable by itself. And to the right, you can plug in any type of processors as you wish, and they are linked to different ambassadors on the fly, so you have this one-to-one sessions.
Right.
So it's a really scalable architecture, and you can see we can, it's open as well, so we can plug in new collectors and new processors at any time. And if we need to scale this out, we can just launch more processors. Then we can.
This is a very common design pattern where you have lots of different types of messaging, and then they normalize them into a message type, and then you can forward those to wherever you want to go.
Exactly. Yeah.
And so these 3, or maybe more, they're running inside that 5 cluster.
Yeah. Everything is on the same Service Fabric cluster.
Cool.
And this is to zoom out a little bit to see actually such a system. What I demoed is just the chatting experience. Actually, the whole system is much bigger than this. Following the same microservice design, you can actually leverage other Azure services, and you can just stitch them together into a complete solution. You can see here at the core, we have the ambassador services written in Service Fabric, but it's leveraging all kinds of Azure services, like Power BI for analysis, and there's even, I think there's a machine learning pipeline. I forgot to put it on.
A BI pipeline.
That's the BI pipeline. But it's also using the document DB as storage, so you can see basically you have the whole ecosystem of Azure services that you can link to the Service Fabric.
Yeah, that's a very common design where you have a little processing around Service Fabric, and then you offload analytics into DocDB for all of the analytics around it.
Yeah. And so that was the ambassador program. Now we are going back to the game itself. So, like I mentioned, Mark was talking about to writing new games. Now I'm talking about to host the legacy games, where you already have a game title. You need to host on the cloud. You want to make it available. And how do you do that?
Like tic-tac-toe?
Well, it's a little more complicated than that. So there are a few challenges when you try to take those legacy games and put it on cloud, right? Most of the games, they are designed for the local network. They're not really designed for the latency you can experience over the internet. And they are usually license-based. You buy a box title that you install on your Xbox or whatever console. But usually on the cloud, you want to have this subscription-based usage. You want to have a meter of usage, and you want in-game sales, all those kinds of things. And also, version management, you can't just buy a new game. You have to roll out your new game versions on the server, so it's available to all the game players. And the last but not least, the anti-piracy is a true concern. Actually, we'll talk about that more in a moment. So to talk about this scenario, I'm going to introduce this scenario from Tencent, which is one of the largest online gaming history in the world. They are hosting hundreds of titles and in tens of data centers across China. And they have frequent releases, updates on those titles. You can imagine that's hundreds of titles times tens of data centers times daily updates. You can imagine how many updates they need to do on a daily basis. So this is a big management problem for them. And at the same time, they have to do this without interrupting tens of millions of concurrent users. That's not a typo, by the way. It's literally tens of millions of concurrent users on their system. And they also have this great concern about privacy and cheats. A lot of people are trying to cheat because nowadays you can actually make good money by playing games. So they went a full length to trying to stop that.
And these titles, they're both new titles that they're writing, and also the legacy ones that you mentioned?
Actually, most of the titles they have are from a third party. So they are taking the existing titles and host it on cloud.
Right.
And that's one of the major challenges they have, because they don't have access to the source code. They cannot make any modifications.
Right.
They have to take the game as it is and try to host it efficiently on the cloud. So to illustrate the solution, I'm going to use Minecraft as a simpler sample. So basically, with Service Fabric, we have this programming model. You can write actors, you can write reliable services using C# on Service Fabric. But we also have container orchestration on Service Fabric. It's a container orchestrator as well. You can host Docker containers on Service Fabric, and it provides load balancing, failover, all this wonderful stuff for you. So in this particular example, I'm going to show you I'm deploying a Minecraft server on a 5-node cluster. And the cluster is configured behind the load balancer, so the client can access the server. But what happens if one of the nodes fails? The container, the Minecraft server, will be relocated to a different node, and your game client can still access to that game instance. I think for that, it's easier to see with a demo. I'm going to switch back to my machine.
Yeah.
Okay. Oh, I'm back to my machine. So I'm going to launch the Minecraft client here. And as it's launching, I'm going to show you the cluster. So basically, this is a Service Fabric cluster. You can see I have this Minecraft server. Let me make it a little quieter. It's too dramatic.
Yes.
So I have this Minecraft server deployed. You can see I have this single instance running on the application host 3. That's one of the node. So I'm going back to my client. Switch to the multiplayer using direct connect. You can see here I'm connecting to this SF-Linux 9, so Central Cloud APP Azure, which is this cluster.
Is the Service Fabric running on Linux now?
Yes. I forgot to mention that. So I'm going to join this server. You can see.
Have you created an interesting world?
No, I haven't this time.
And it's the night.
Yeah, it's not right. But I'm going to fix that. So I'm going to party. I'm going to connect to one of the machines. Which host is that? That's host 3.
Yeah.
So I need to connect to the right port. Oh, I'm doing so many commands.
Yes.
Where's my SSH command?
It
will come up, I'm sure. Jeez. Okay, no. So 89 is the first one, 90 is the second one, so the 91 will be the third one, 92 will be 3, yeah.
Yes,
Okay.
that's the default ports you get. Yes.
So now I'm on the instance. I can do a sudo docker ps. You can see actually this is my Minecraft server. It's launched about an hour ago. And I can do a sudo docker run -i. No, exec -i.
So you're launching that container?
Yeah, I'm going to. I'm going to connect to that container and launch the client. So I'm going to do a time set 1,000. I think that will change it to morning. You can see, yeah.
Nice.
I'm actually on that server. I can do all this stuff. So now I'm happy. I'm happy playing the game. I'm going to do something bad. Yes.
Just to understand, that Service Fabric with the 5 nodes, they're running Linux. You SSH'd into one of those nodes, node 3, and then connected to the Docker that's running inside of that node. And then ran the command to change the time on the Minecraft server.
It's like Inception. It's multiple layers going there.
Cool. Yep.
And right now, Minecraft is only running on one node. On
Yes.
This specific node. Okay.
Yes. And actually, what I also want to show you. Actually, let me do this first. So my game is running, right? The game client is still running here. I'm going to go to my host. That's the single instance, right? So I'm going to shut down this single instance. That's really bad.
We get you to type a lot in order to shut it down. It's,
Okay.
Don't try to do that at home.
Yeah.
So now the node is being deactivated, and you can see the instance is gone at the moment. And in the moment, you can see a new container will be launched in a different host. So this should take just a few seconds.
Is it a by default compartment like behavior, or do you had to set up something specifically to have this? Like
No, this is automatic behavior.
Automatic.
Basically, I'm specifying my application needs one instance running. So Service Fabric will make sure I will always have one instance running. Right?
Cool.
Yeah.
You can see now the server has been migrated to a different host. I'm still in the game. I'm still happily playing Minecraft. So the one important thing to note is that I didn't change anything. Right? This is a public Minecraft server image I got from Docker Hub. So if I do GDC, actually, if I do the, I need to find them. Minecraft. If I look at the service manifest, you can see that's the Docker image name, right? This is not my private image. That I did nothing to the image.
Right.
I just set up some environment variables to the image that I just launched it and managed to by Service Fabric.
Yeah, and here you're looking at the Service Fabric manifest that
yeah.
describes how to launch containers inside there.
Yeah.
And you can launch. So
Right.
you can do. So the great thing about Service Fabric is you can launch just an executable or a container, or you can build new code and launch it that way as well.
Right.
So what I think is very interesting is that you can take existing code and just move to Service Fabric, but you get all the benefits of failover, reliability, and management and rollout. It's mostly around that. Or you can do what I was doing earlier, is you can build new code and then take advantage of that, and you can mix and match the two. I think it's great that you can host existing code and just take that first step.
Yeah.
So what happens there during the failover from what you had in node 3 to the other node that it moved over to?
Yeah.
Does it only tear it down after the other one is running, and then does the failover to it, or?
Well, it makes sure, I mean, in this particular case, he shut down it safely. There's actually a little bit of short timeout that you can configure
Right.
to make sure that it's safely shut down, and we make sure that that is gone before you launch a new one.
Okay.
So you can guarantee, one of the things that Service Fabric does is you can guarantee through what's called leader election that there is one and only one of anything running if you want to have that. If you want to have 5 running and only 5 running, you can specify that.
Right.
So sometimes in a lot of these systems, you may have 2 running. This one is still there and this one's launching and you're not too sure when it's come up. But Service Fabric provides guarantees around leader election process that things are not running. And in this case, you actually had, when you shut that down, you can actually configure the time it detects and relaunch it as well.
Yeah. Yeah, and another feature I'm using, this is a new feature coming out, that you can actually attach data volumes to your containers.
Right.
So in this case, my Word file is actually on the data volume based on Azure files.
Okay.
So although the container itself is destroyed, my Word state is still saved on the file. Then when the new container comes up, it can just pick up the same state.
So that's why after the failover, it just continued to
continue
work
to
as the normal
see the
game.
same word. Yeah.
Okay.
Yeah.
Yes.
Awesome.
So can we switch back to the slides?
I feel all calm with Minecraft music.
Yeah.
Relaxing.
All right, we're back. So basically, I showed you the concept how to take a legacy application, containerize it, and host it on Service Fabric. And what Tencent did, they were trying to do the same concept, but they are pushing this one step further. So remember, I was talking about the piracy concerns, the cheating concerns. So in the traditional deployment, they have the game server in their data center, and they have game client on the client machines, whatever, PCs, consoles. And what they did was to move everything onto the server and basically have a new client player that installed on the actual client machine. And what the client player does is to stream the keyboard and mouse event to the server client, and then stream the DirectX instructions back to the client. So in this way, they have a really thin client installed on the machine. So there's a really lower chance of piracy and cheat in this case.
And in this case, the rendering is still everything.
Yeah, the
is
rendering
done
is
in
still done on the
client.
client. They're
Okay.
just streaming the DirectX instructions back to the client.
It's more like, can I do this? Yes. Kind of communication, or can I go up, or is it checking the commands on the server?
So basically, you can think the client player just as a remote console. It's remote consoling into the actual game client running on the server. So all the keyboard events are actually handled by the game client on the server.
Got it.
And all the commands are streamed back and they're rendered on the client player. And they are also using Service Fabric to have this tenant manager. So basically, here you can see another pattern of a very large scale deployment where you have a dedicated control plane that manage your workloads, and then you have like one or many compute planes where you can actually host your workload. And
So just a quick question.
Yeah.
The game client to client player, is it a one-to-one instance
yeah,
that
that's
they have?
one instance.
So they just instantiate a new instance on Service Fabric for each client player.
Yeah.
Cool.
Yeah, and you can scale out the server and the client horizontally. And for that, I will just show you a quick demo.
Switch back to your machine.
Yes.
It's there, all right?
Yeah. Actually, this is a video of this system in play.
Cool.
Actually, there's two music playing. But you can see actually they got fairly good frame rate. It's 30 frames per second. It's not great. It's not 60 frames per second. But you can see from the experience is okay. And they are deploying this on many data centers in China. So that's another benefit of Service Fabric, right? You can run Service Fabric locally. You can run it on Azure, and you can also run it on any data centers you like.
Right.
And in
So
their
they're
case,
running it on their data set.
yeah, in their case, they want to minimize the latency, right? So they have to host in their local data centers in major cities in China to provide low latency to the players.
Yeah, in fact, we have a lot of customers who take Service Fabric and run it in their data centers today, and that's where because they might have compliance requirements and things like that, and more restrictive, and then, or in this case, they have latency requirements, but it allows them to take that and host it in Azure at a later date, so that migration can happen.
Cool.
Yeah, let's go back to the slide. I think I am done with all my demos as well.
Yep.
Yes.
Oh,
there
yes.
you go.
Yes, I think you're done with the demos.
Yeah, I'm
and
done.
This was a bit of a wrap-up, wasn't
Awesome.
it? We have this little Service Fabric video, which I say is always great to watch because it helps explain Service Fabric to your mother.
Right.
And you can play it and it tells you what a microservice is and or the environment. So it's at the aka.ms Service Fabric video.
We'll make sure to add those to the links below the show as well.
Yes, and then these are some just great links that we will summarize in terms of where to find that game framework and download that. The tic-tac-toe sample there we looked at the beginning, and there's generally the SDK and the docs. And we love questions all the time, and Stack Overflow and GitHub issues are the two places that we love to hear feedback from and things like this. So that's a set of resources about what we've seen today and things.
Awesome. And you're on Twitter, I know, Hashi.
Yes.
What's your alias?
Haishi by 2010, I think.
All right.
Yes. I'm on Twitter. Mine's mfussel at Twitter.
Great.
And then we have Azure Service Fabric.
Oh yeah, that's an important one.
Is the other one that we send a lot of tweets about, like this recording.
Cool. All right. Thank you guys very much. This was awesome. I didn't know there were so many games running on top of Azure Service Fabric, so I'll need to check out these links. And to everyone at home, thanks for joining us. Thanks, Etienne, for the questions. And we'll see you next time.
Thank you.
Thanks.
Bye.